Hello everyone, welcome back. So today we will be entering chapter 8, which is on rotational motion of rigid body. So in this subtopic, in this chapter there's 4 subtopics, and the first one is on rotational kinematics. Okay, so in this subtopic you should be able to define and use angular displacement, average angular velocity, instantaneous angular velocity, average angular acceleration, and then instantaneous angular acceleration. Okay, so you have to also be able to relate parameters which is in rotational motion with their corresponding quantities in linear motion. Okay, and then lastly you should be able to solve problems related to rotational motion with constant angular acceleration. Okay, right, so the first one is angular displacement, which is theta. Okay, so this is the angle theta is the arc length is subtended by an arc length s, which is this one, along a circle of radius r. Okay, so it is measured in gradients counterclockwise from the positive x-axis. Counterclockwise means it is anti-clockwise lah, so anti-clockwise from the positive x-axis, which is this one. Okay, and then it is the difference between theta final minus dengan theta initial with the SI unit of radian. Okay, and the next one is average angular velocity, which is omega AV. It is defined as the rate of change of angular displacement. Okay, so the rate of change of angular displacement is our theta lah. Okay, the formula is given here, and then it has an SI unit of radian per second. Okay, and then we have instantaneous angular velocity, which is just omega. It is the limit of average velocity when it is approaches zero. Okay, so that is the formula here, and it has the SI unit of radian per second. And then average angular acceleration, which is the rate of change of angular velocity. Okay, so tadi is the rate of change of angular displacement, that is for angular velocity. Okay, and then if it's on acceleration, it is the rate of change of angular velocity. Okay, so this is the formula given here, and then it has an SI unit of radian per second squared. Okay, and then lastly it is instantaneous angular acceleration, which is alpha. So this is the limit of the average angular acceleration as time interval approaches 0. Okay, so that is the formula given here, and then it has the SI unit of radian per second squared. Okay, right, so how do we determine the direction, whether it is positive or negative? Well, if we have an anti-clockwise direction, our thumb is pointing up, meaning that the angular velocity is positive. Okay, but if we have a clockwise punya angular velocity, it means that the angular velocity is negative. Okay, because our point, and then our thumb is pointing down lah, so negative. And then for the angular acceleration pula, if the rotation is speeding up, okay, so make sure you can see this one, it is speeding up. If it is speeding up, alpha and omega will be in the same direction. Okay, tapi if it slows down, if it's slowing down, then the alpha and omega will have opposite direction. Okay, so macam contohnya for this clockwise ni, if it is slowing down, then the alpha is in the opposite direction with the omega lah. Okay, so this is the analogy of linear motion with rotational motion. Okay, so we've learned linear motion, contohnya v equal to u plus at semua ni. Okay, so if we were to relate this to rotational motion, relate to linear motion, this is the table that you have to see lah to understand. Okay, so acceleration, linear acceleration is constant, which is the same with angular acceleration, constant juga. Okay, so v here is the omega, u here is the initial omega with so omega naught lah, maksudnya itu initial velocity. This one untuk ini initial angular velocity, yang ini initial velocity, linear velocity lah. Okay, so just make sure you understand what is s in terms of rotational motion, what is our acceleration in terms of rotational motion. Okay, so that is just what you need to know, the relationship between them. And then we also have relations between angular and linear quantities. Contohnya, if we were to find the length of arch, linear arch, we are gonna use our theta. Theta is still the angle lah. And then in radian lah. Lepas tu, if we were to find the angular velocity by using linear punya quantities, we can use this formula. The same goes to this formula acceleration lah. Okay. Right, so that is basically the theory part for subtopic 8.1, which is on rotational kinematics.